In the United States, over 60 million people have their ability to play video games inhibited by their disability. We, Team Absolute Zero, from UW-Madison's Interdisciplinary Engineering 170, Lab 311, set out to reduce that number. Our client Darren Belden had a stroke, causing limited mobility in his left arm. Our challenge? Create a body-controlled joystick that allows our client to use the WASD keys without his left hand, so that he has an easier time playing video games.
We started with an initial brainstorming session. At the beginning, we had numerous ideas on how to solve our problem, ranging from eye trackers to multi-input pedal controls. But then we narrowed our initial ideas down to a top 4: the baseball cap design, the foot touchpad, the foot pressure pad, and the chair sensor design. Eventually, we decided on the baseball cap design since it was the most accurate, the least cumbersome, and our client liked it the most. We quickly started making adjustments to that initial idea. We found that instead of a baseball cap, a head strap would be more suitable for our project and comfortable for our client. We got rid of our cable connection to the computer and made this a Bluetooth connection. We also found an Arduino with a built-in accelerometer and Bluetooth capabilities, which simplified the design overall.
After adjusting our preliminary design, we started ordering our materials. The Arduino Nano 33B LE Sense, which has Bluetooth adaptability, as well as the built-in sensors necessary for our project, like the accelerometer. A switch and a potentiometer to allow easy control of the on-off function and variable sensitivity. A battery and battery charger that is light, small, powerful, and rechargeable. We then 3D printed a box for the housing to hold all of these materials so that it is custom fit to the head strap and has minimal bulk. Lastly, a head strap that can be adjusted for fit and has a built-in attachment for the housing.
Our fabrication began with our code. We first created an Arduino code that reads the inputs from the accelerometer on the Arduino and turns that into Java-readable outputs. Our processing/Java code then reads those outputs via serial port and turns it into WASD/keystrokes that can actually interact with the desktop game. With the Arduino ready, we soldered all components together. For our design, the Arduino only needs 2 inputs, a power source and a potentiometer to change the gain. The lithium polymer battery acts as the power source. It is connected to a charger, which then connects to the Arduino, making the joystick rechargeable. There is also a switch that will be used in coordination with the power source, so the joystick can be turned on and off. The Arduino also takes inputs from the potentiometer, which is controlled by twisting its dial, and these readings adjust the sensitivity of the joystick.
In testing, we wanted to look at the accuracy, the delay, the functionality of the circuitry, the comfortability of the product, and the durability of the product. To test the accuracy and the delay, we used a website that flashed WASD and would record the keys that was pressed and recorded the time that it took for the user to press those keys. We tested all of these circumstances in regards to circuitry to ensure that it worked. Many people wore and used the joystick to quantitatively measure the comfort while using the product and qualitatively measure the durability over time. Unfortunately, we did not achieve a consistent Bluetooth connection with our product, so we reverted to using a USB cable to connect the joystick to the computer. Other than that, we concluded that the head tilt joystick meets all requirements set by our client.